Welcome back, everybody, for another deep dive. This time we're um, tackling how systems like YouTube manage to handle those massive amounts of traffic. Like when a video goes viral and suddenly everybody and their grandma is trying to watch it.
Right. Yeah, it's a fascinating challenge.
It really is. And we've got a really interesting paper to dig into today called Load is Not What You Should Balance, Introducing Prequal.
Hmm.
And it's straight from the source, the engineers at Google.
Yeah, this paper really kind of shakes up some of the conventional wisdom around load balancing in these large distributed systems.
Yeah, for sure. So maybe we can start with you giving us a little bit of a behind-the-scenes look at what's actually going on when we're talking about a service at YouTube's scale. I mean, we're talking about a truly massive network of interconnected processes, tons of machines, all working together. So how do they make sure everything is running smoothly?
Well, it's all about making sure that each piece of this puzzle is getting the resources it needs to perform optimally, right? You don't want any single machine getting bogged down and becoming a bottleneck for the entire system.
Right. And I guess the intuitive approach would be to just try and balance the CPU load across all these machines, right? Make sure no one machine is getting overloaded.
Yeah, that's the classic approach, and it makes sense on the surface, but what this research really highlights is that focusing solely on CPU utilization can sometimes be misleading.
Okay, how so?
Well, think about it. Let's say you have a sudden spike in user activity, like that viral video scenario we talked about. Even if your overall CPU capacity is enough to handle it at very short timescales, you might have individual machines hitting their limits because other processes running on the same machine are competing for resources.
So even though things might look balanced on average if you zoom in, you might see these hidden spikes in CPU usage that are actually impacting performance.
Exactly. And that's a key insight from this paper. They're saying we need to look beyond these trailing indicators like CPU usage and start focusing on more immediate and more predictive signals like request in flight and latency.
Okay, so requests in flight. I guess that's basically how many requests a particular machine is juggling at any given moment. And latency is how long it takes to process those requests.
Exactly. By monitoring these metrics, Prequel can get a much clearer picture of which machines are truly overloaded and which ones have capacity to spare.
Got it. So this is where it starts to get really interesting for me. How does Prequel actually decide which machine to send a request to? What's this hot-cold lexicographic rule all about?
It's kind of like a two-step decision process.
Hmm.
First, Prequel will prioritize machines that are within their RAM limits. This makes sure that no machine gets so overwhelmed that it starts dropping requests or slowing down significantly.
So it's like making sure no server is drowning in requests.
Right. And then among the machines that have RAM to spare, Prequel favors those with the lowest latency to make sure requests are handled as quickly as possible. So this hot-cold approach, it strikes the balance between utilizing resources effectively and being responsive, which in the end makes for a smoother user experience.
One of the things that really stood out to me in this paper was the amount of real-world testing they did. They didn't just run simulations. They actually deployed Prequel on YouTube itself. What kind of results did they see?
The results were pretty impressive. By using Prequel, YouTube managed to cut their tail latency in half. That means fewer users are experiencing those annoying delays when they're trying to watch a video. They also saw a 5 to 10 times reduction in those peak RIF values, which basically means the system was much more stable and resilient under heavy load.
So it's not just about making things faster. It's also about making them more reliable. And that's a huge win for both the users and the platform itself.
Absolutely. This research is really challenging that traditional idea that balancing load is all about getting an even distribution of CPU usage. What Prequel shows is that a more nuanced approach, one that considers real-time factors like RIF and latency, can lead to significant improvements in both performance and reliability.
It sounds like they found a smarter way to manage resources, adapting to the ebb and flow of demand, instead of trying to enforce this rigid balance.
Yeah, that's a great way to put it. It's about making sure that every single request finds the optimal server ready to handle it quickly and efficiently, no matter what the overall load on the system looks like.
This all sounds incredibly promising, but I do have to wonder about the overhead involved in constantly monitoring RIF and latency. I mean, sending out all those probes to gather information has got to add some burden to the system, right?
That's a great question. And yeah, it's something the engineers behind Prequel definitely took into consideration. They designed the system to be surprisingly lightweight.
Okay.
First of all, those probe responses, they're incredibly fast. We're talking sub-millisecond response times within a data center.
So there's not a lot of lag involved in getting that real-time feedback.
Nope. Plus, Prequel uses a really clever asynchronous probing mechanism. So basically, it maintains this pool of recent probe responses, almost like a snapshot of the system's state. And that means it doesn't have to wait for a fresh probe response every single time a new request comes in.
So it can make quick decisions based on, recently gathered information without slowing down the actual processing of requests.
Exactly. And to fine-tune the whole process, Prequel has a number of adjustable parameters. You can control things like the probe rate, how long those responses are considered valid, even how often you prune the pool to avoid any bias. It gives operators a lot of flexibility to optimize the system for their specific needs and environment.
It's like having a set of dials to fine-tune the balance between gathering fresh data and, minimizing overhead.
That's a great way to put it. And here's something else that might surprise you. Prequel actually performs really well, even with a relatively low probe rate.
Really?
Yeah, you might think you need constant updates to get an accurate picture, but the research found that even with something like one probe per query, Prequel was still outperforming those traditional methods.
It sounds like they found that sweet spot between getting enough information to make good decisions and avoiding unnecessary strain on the system.
Right. But it's important to remember there is this fundamental trade-off. More frequent probes give you a more up-to-date view of the system, but they also require more resources. The key is finding the right balance for your specific application.
They actually did experiments to test this trade-off, right?
They did. They gradually decreased the probe rate and observed how it impacted Prequel's performance. And what they found was pretty interesting. The performance remained relatively stable even as the probing rate went down. It wasn't this sudden drop-off. It was more of a gradual decline.
So it wasn't like pulling a rug out from under the system.
No, not at all. And even with a lower probe rate, Prequel was still doing significantly better than those traditional CPU balancing approaches. However, they did find this kind of critical threshold around one probe per query. Below that point, the performance started to deteriorate a bit more noticeably.
Yeah, that makes sense. At some point, you need some minimum amount of information to make those smart decisions.
Exactly. And it highlights the importance of that hot-cold logic we were talking about earlier. That RIF threshold plays a crucial role in preventing overload situations and keeping things stable.
We've been talking a lot about the theory behind Prequel, but I'm curious about how those tuning parameters actually play out in practice. Did the researchers get into that level of detail?
They did. To really understand how those parameters impact performance, they designed a really clever experiment using a testbed with two types of replicas.
Okay.
They had these fast replicas representing machines with more processing power, and then they artificially slowed down some of the replicas to simulate differences in hardware or other things that might enrich performance.
So they basically created a controlled environment where they could experiment with different configurations.
Exactly. And then they started tweaking that RIF threshold, the QRIF parameter, to see how it impacted both latency and the distribution of CPU utilization. It's like they were adjusting the system's sensitivity to overload conditions.
I imagine that setting that threshold too low would lead to underutilization. The system would be too cautious, hesitant to send requests to machines that could actually handle them.
Right. And on the other hand, setting the threshold too high could lead to those overload situations we're trying to avoid. So finding that sweet spot is really key.
What did they discover as they experimented with this threshold? Did they find that prioritizing low latency inevitably led to some machines getting bombarded with requests?
It's actually a bit more nuanced than that. As they shifted towards prioritizing low latency, those latency numbers did improve, as you might expect. But what's interesting is that even with a fairly high RIF threshold, meaning they were really emphasizing latency, the RIF stayed remarkably well behaved.
It's like the system could have its cake and eat it too.
I know, right? They managed to find this balance where they could optimize for speed without causing those requests to pile up and overwhelm certain machines. However, they did make a really interesting discovery when they went to the extreme of pure latency-based selection, completely ignoring RIF.
Now that seems counterintuitive. Wouldn't focusing only on getting the fastest response times lead to the best overall performance?
You'd think so, but it turns out that ignoring RIF entirely can actually be detrimental. Remember, RIF is a leading indicator. It gives you that early warning signal that a machine might be approaching overload. If you're just focusing on latency, you're essentially reacting to problems after they've already happened.
It's like trying to steer a car by only looking in the rearview mirror. You're always playing catch-up.
Exactly. And that's why this combined approach in Prequal, using both RIF and latency, is so powerful. It's like having both a speedometer and a GPS. You can anticipate potential issues and adjust proactively instead of just reacting to what's already going on.
So Prequel isn't just about reacting faster. It's about anticipating and adapting to changing conditions in real time.
Exactly. The researchers really dug into why this approach was so successful, and they found that when you just focus on latency, you can end up with an uneven distribution of load across those fast and slow replicas. The fast ones end up getting hammered with requests, creating bottlenecks, while the slower ones are sitting there underutilized.
It's like everyone crowding into the express lane at the grocery store while the other checkout lines are empty.
Exactly. And that imbalance can actually lead to higher latency overall. Those overloaded fast replicas become bottlenecks, slowing down the whole system.
So it's not just about picking the fastest route for each individual request. It's about optimizing the flow of traffic across the entire system.
Right. And that's what Prequel does so well. By taking RIF into account, it prevents those fast replicas from getting completely swamped.
Yeah.
And that leads to a smoother, more efficient system overall.
It sounds like they've hit on a fundamental principle here, that true efficiency comes from understanding the interplay between responsiveness and resource utilization.
That's a great way to put it. And what's really exciting is that this has implications far beyond just CPU and RAM. The principles behind Prequel could be applied to manage all kinds of resources in a distributed system.
We've talked about CPU and RAM, but what other resources could benefit from this kind of approach?
Well, think about things like network bandwidth, disk I/O, database connections. Any resource that can become a bottleneck in a distributed system could potentially be managed more effectively using these principles.
So we could see prequel-inspired approaches being used for everything from cloud gaming services that need to adapt to fluctuating network conditions to e-commerce platforms that have to deal with massive traffic spikes during big sales.
Exactly. The possibilities are huge. And that's what makes this research so groundbreaking. It's not just about solving one specific problem, it's about introducing a whole new way of thinking about resource management in complex systems.
It's pretty amazing to think that a single research paper can spark such a wave of innovation.
It really shows the power of challenging conventional thinking and, exploring new approaches.
Mm.
And it highlights how important it is to really understand how these complex systems work instead of just relying on, those simplistic assumptions.
This has been a fantastic deep dive.
Mhm.
I think our listeners are walking away with a much better understanding of not just how services like YouTube work, but also the future of intelligent resource management.
It's been great talking about this with you.
And as always, we encourage you to keep on diving deeper. Explore those endless frontiers of knowledge and understanding. Until next time. It really is amazing to see how just changing your perspective a little bit,
Hmm.
moving from that static load balancing to this more dynamic approach can make such a big difference. And it feels like we're just scratching the surface here.
I think so too. This paper has really opened up a whole new way of thinking about resource management. And it's not just that they showed how effective Prequel is, they also went deeper to figure out why it works so well. They really wanted to understand those underlying mechanisms behind the results.
They weren't satisfied with just knowing that it worked. They had to figure out the how and the why.
Exactly. And through their analysis, they uncovered some pretty interesting insights. Remember that kind of counterintuitive finding we talked about where focusing only on latency ended up making performance worse?
Yeah, that seemed to go against common sense.
Right. Well, their investigation showed that this was actually happening because of an imbalance in how the load was being distributed across those fast and slow replicas. When the system only prioritized latency, it ended up overloading those fast replicas, which created bottlenecks that actually slowed down the whole system.
So even though those fast replicas were handling requests quickly on their own, the sheer number of requests they were getting ended up creating a bottleneck that negated any gains they were making.
Exactly. It's a classic case of how making things better at a local level can sometimes backfire and lead to worse results overall.
It's like focusing so much on one tree that you lose sight of the whole forest.
Perfect analogy. And that's where Prequel really shines. By considering RIF, it prevents those fast replicas from getting overloaded, which makes the whole system run smoother and more efficiently.
It's like Prequel is this smart traffic controller directing requests to the best places based on real-time conditions. It's not just about speed, it's about making sure everything flows smoothly across the whole system.
Yeah, that's a great way to picture it. Prequel is constantly monitoring and adjusting, making sure every request is handled efficiently without overwhelming any one part of the system.
This deep dive has really given me a new understanding of how complex load balancing is in these big distributed systems. It's not just about splitting the work evenly. It's about intelligently allocating resources to handle changing demands and keeping everything stable and responsive.
And the exciting thing is that this is just the beginning. The ideas behind Prequel have the potential to change how we manage resources in all kinds of systems, everything from cloud platforms to big data processing.
It's amazing how one research paper can spark so much innovation.
It shows how powerful it can be to challenge what we think we know and try new things, and emphasizes how important it is to really understand the dynamics of these complex systems instead of just relying on simple assumptions.
This has been a fantastic deep dive. And I'm sure our listeners have learned a lot not only about how systems like YouTube work, but also about the future of intelligent resource management.
It's been great diving into this with you.
And as always, we encourage everyone to keep exploring those endless frontiers of knowledge and understanding. See you next time.